These are the notes on solubility. You should have already completed the solutions vocab assignment before you start these notes. So what is solubility? This unit we're talking about solutions. And so as we're talking about solubility, solubility discusses the amount of solute that dissolves in a given quantity of solvent at a given temperature to form a saturated solution. So again, solute is the thing that is being dissolved. We have less of that. The solvent, that is the chemical that is doing the dissolving, and those form a solution. And so we can describe solutions in terms of their saturation. And that saturation, that point of saturation, varies depending on the chemical that you're working with. So think about your past experiences. Does sugar or salt dissolve easier in hot or cold water? And why do you think that is the case? Take a minute and think. In my experience, these dissolve easier in hot water. And that means that more can also get dissolved. We are often going to be discussing water as our solvent. This applies if we have something else that's doing the dissolving as well, but often we're making solutions with water to get aqueous solutions, so that's why we often are discussing solubility in terms of that water temperature. Why do I think that's the case? Well, temperature, if something is hot, that means that the molecules are moving more quickly. So molecules move faster, and if those are going to move faster, then that is kind of mixing that solution easier. That increases that solubility. Water with a colder temperature, those molecules are going to be moving more slowly, and so less is going to be dissolved. As we are looking at modeling solubility, we use solubility curves. Solubility curves are graphs that show the maximum concentration of a solution at a given temperature. So on those graphs, we are going to have solubility on the vertical axis. We are going to have temperature on the horizontal axis. In science, we use degrees Celsius. And sometimes you'll have solubility of just one chemical, but often we can see solubility of multiple chemicals on this graph. You'll notice solubility is measured in grams per 100 grams of water. And so that unit is how many grams of solute gets dissolved per 100 grams of solvent of water. And so we need some amount of water in order for there to be dissolving. So it keeps that amount of water constant. And then we can vary and look at the variations in as temperature changes. How will that impact how much can get dissolved with that? So reading a solubility curve, if we are talking about saturated solutions are solutions that contain the maximum amount of solute that can be dissolved. No more solute will be able to dissolve in the solution, so if more was added into the solution, it is not going to dissolve. It would stay in a solid state. So any point that is on the solubility curve represents a saturated solution. So if you look at the starred points here, those are representing a saturated solution. One thing to consider, how does the solubility of a substance change as the temperature increases? As we look at our graph here, temperature is increasing to the right. So what is happening with our solubility? Well, it appears to me that as that temperature is increasing, the solubility is increasing as well. We saw that on this graph as well with that potassium nitrate. You'll notice it is increasing slightly with our sodium chloride, which is table salt, but that temperature doesn't have quite the same change on that sodium chloride as it does potassium nitrate. So it does depend on the chemical. As we look at this same graph for the solubility of potassium nitrate, If we are looking at supersaturated solutions, that's where more solute is dissolved in the solution than is normally possible. We can find, or we see that any point above the curve is going to represent a saturated solution. So we have a few points that are marked on here. Anything in this area would represent a supersaturated solution. So seeing those triangles as different examples. And then lastly, we have unsaturated, or these can also be described as dilute solutions. That means that more solute will dissolve into the solution if added. So any point that is below or under the curve represents an unsaturated solution or a dilute solution. So we can see those points that are marked with circles representing unsaturated or dilute solutions. So we can get information about our solutions from this graph. If we know how much is dissolved, we can determine what temperature maybe that solution is at. So we're going to do some practice on answering some questions by reading these graphs. So we are given this solubility of potassium nitrate graph here, and using this solubility versus temperature graph in order to answer the questions. What is the solubility of potassium nitrate at 40 degrees Celsius? If I'm looking at this one, I'm going to go to that 40 degrees Celsius on my graph, and I am going to look for, well, what is that, where is that crossing the solubility curve? We can see that here, that's where my graph is intersecting, and now I'm able to then look over to my temperature or my solubility axis and see it looks to me that that is about 65, and then our units would be grams per 100 grams of water. That is the solubility of potassium nitrate at 40 degrees Celsius. So 65 grams of that potassium nitrate, KNO3, would be able to be dissolved in 40 grams of water. Number 2, at what temperature will the solubility of potassium nitrate be 50 grams per 100 grams of water? Similar to the question we were just asked, but we are now going to use that 50 grams per 100. So going over here and seeing, well, where is that intersecting on my graph? That intersection is right here. Oops, that's a little off, right here. And so then again, looking down to our temperature axis, each of these markings are 10, so this would be 5. So to me, it looks like it's maybe at 32. And then we need degrees Celsius is the temperature where the solubility would be 50 grams per 100 grams of water. All right, how many grams of potassium nitrate can be dissolved in 100 grams of water at 20 degrees Celsius? Feel free to pause if you are comfortable trying the next couple on your own. So now we're looking at that 20 degrees Celsius. Notice that, that 20 degrees Celsius, using our 20 here, and then trying to determine from there what solubility that represents. To me, it's between that 30 and 40. I don't know if it looks quite halfway. You could say 35. I'm going to say 34 grams of potassium nitrate will be dissolved per 100 grams of water. All right. Looking at this next graph, we have the solubility of multiple chemicals in here, so we're going to just have to make sure we're finding the correct chemical that the question is asking for. How would you describe a solution with 110 grams of NaNO3 dissolved in 100 grams of water at 20 degrees Celsius? So this one's giving us a specific point. We've got that NaNO3. NaNO3 is right here. We are looking at finding that 20 degrees Celsius with 110 grams. So 20 degrees Celsius is here. My 110 grams is here. So I am looking at comparing this pink dot with that curve. And so how would I describe this solution? Because this is above the curve, I would describe this as being supersaturated. Looking at number 5, how would you describe a solution with 70 grams of potassium nitrate dissolved in 100 grams of water at 60 degrees Celsius? So we're looking now at that potassium nitrate line. So that KNO3, that one's right here. Again, looking at 70 grams, which is this, at 60 degrees. And so those are going to intersect here. And so compared to my line, this is below the line, so I would say that this is unsaturated, or we could describe that as a dilute solution. Looking at number 6, how would you describe a solution with 71 grams of HCl dissolved in 100 grams of water at 20 degrees Celsius? So we are looking at that hydrochloric acid. Finding that on my graph, that one is right here. So we've got 71 grams, which is just above that 70. 20 degrees Celsius is here. So to me, it looks like that is right on the line. And so because it's right on the curve, that would be a saturated solution. How many grams of HCl can be dissolved in 200 grams of water at 30 degrees Celsius? Well, we're still looking at that green line, but now we are going to be looking at a different temperature, so 30 degrees Celsius. So going to that 30 degrees and actually reading, well, where is that line intersecting how many grams of solute would dissolve? To me, that looks like it's about at that 65 grams, and that's for 100 grams of water. And so if this is asking for 200 grams of water, I can do that 65 times 2, and that would be 130 grams of HCl would be able to dissolve in 200 grams of water. So we're just changing the sample of our solvent, and so then we just need to double how many grams of our solute would be able to be dissolved. So how can we model solubility? If we're going to model sodium chloride solution with the stated solubility, we've got some beakers with water here. One thing to know is that when an ionic compound dissolves, it will break into its positive and negative ions. So sodium chloride will dissolve into positive and negative ions. When I'm looking at this, I'm going to model my water molecules on here. I'm going to add water molecules into each of these beakers. I'm going to just do a little copy so that they all have the same amount of water in them. So those dots are just representing our water molecules, our solvent. If we are going to model a dilute or an unsaturated solution, that means that we are going to have not a lot of that solute. So I want to maybe put in just maybe 2 of each of those ions. And so kind of showing that there is room for more to be dissolved, but that there is some dissolved in that water. As I look at my saturated solution now, this is going to be at a point where it doesn't look like more is going to dissolve. And so I'm going to be adding more in. I did 4 positive sodiums. I'm going to do 4 chlorines. This is a 1-to-1 ratio, so we need to make sure however many of each we have, those are the same. It looks like I can fit some more in here, so I'm just showing that there's a lot that is dissolved. And for me, I'm going to say this is my saturated solution. And how is this saturated solution going to change from my supersaturated? Well, I'm going to have everything that could dissolve in there, but if it's supersaturated, that means there's going to be even more than would normally. So adding even more than it looks comfortable for it to have, I'm just changing colors so we can see. And at a certain point, those aren't going to dissolve, and so we're going to still have sodium chloride solid in this as well. So we're going to have solid, which is going to stay in a compound, along with our dissolved ions. That is the end of the solubility notes. There is a solubility curves worksheet available for practice. A check-in is available, and then you are going to complete a pivot on solutions and solubility, practicing these concepts as well. Reach out to your teacher with any questions.